One of the pillars of today's virtual product development is the use of FEM simulation in order to analyze different design configurations, load conditions, or scattering influences in terms of material properties, measured loads, and many others. ANSYS Workbench provides a continuous parameterization and organization of input parameters and output parameters, which can be handled on the project page. Entering the parameter set, one can clearly see all classes of used parameters. They can be defined in the CAD system, as an ANSYS mechanical APDL parameter, as a meshing size parameter, or a material property. Moreover, parameters can be imported from an Excel sheet, or they can be defined within the simulation environment with respect to boundary conditions or result objects. The following example focuses on a flange bracket. It is based on a welded structure which enables the use of different sheet metal thicknesses. When installed, it will be mounted with two walls supported of a neighbored structure. Therefore, a fixed support and a frictionless support are defined. The load is represented by a force directing perpendicularly to the cylindrical lug. The design goal is to minimize the weight by varying geometry parameters, while the maximum deformation should not exceed 1.5 mm to meet tight tolerances. Let's take a look at the process of parameterization. First of all, we want to define 4 geometrical parameters which can be activated on the CAD system, in this case the ANSYS Design Modeler. One of them should control the angle of the web. The 3 others control respectively the thickness of the used sheet metals, that means the upper flange, the bottom flange, and the web. Therefore, we add a check mark at the parameter box next to every dimension, which should later be used as an input parameter. After that, we can see that a parameter set is now available on the project page. The arrow indicates that input parameters will have an effect on the simulation results. In the static structural analysis, we want to activate the output parameter for the mass and the appearing maximum deformation. Many more parameters would be available, such as material density or equivalent stress. Returning to the project page and entering the parameter set gives an overview of all defined parameters. They are grouped in input and output parameters. On the right side, the table of design points shows only the current design point. It can be complemented easily, for instance, by inserting a prepared table from an Excel sheet. This kind of design point table is also called what-if study. Selected design points may be exported into single ANSYS Workbench projects, which facilitates design review. Now, only one mouse click is needed to start the automatic process of calculating all design points. Options for the updating process in terms of remote solving or data management are also available. After solving, one can choose the most suitable design. But let's keep in mind that there are also tools in ANSYS Workbench available, such as Design Exploration, which enable an efficient sampling, scanning the design space. The result of a so-called design of experiment is then the basis for professional design optimization. To summarize, ANSYS Workbench offers a continuous parameterization of input and output parameters. Many different sources of input parameters and a well-organized overview within a design point table allow a fast understanding of the influence of parameters and, in most cases, a design improvement. Combined with the automated process of computing design points, the user carries out conveniently and efficiently design studies. Now it's up to you to gain more knowledge of your design by using parameters in ANSYS Workbench.